For these last two examples, you can approach these in a different way. The first one you can break into shapes that are familiar and then add the areas of the individual shapes together. So for example, you could just continue drawing that line down, and then you've got a rectangle here, which is 3 centimeters across this way and 16 centimeters across this way. So you can do a 3 by 16 on there. Likewise, you've got a congruent piece over here, which is 3 by 16. And then for the parts here, if I look at this part, it is definitely 3 this way. And across here, we could figure this out. This is 3 centimeters. We know that that length would be 22. Take away the 3 from the left of it, and then take away another 3 from the right of it. And that would give us a length of 16 here. So again, we have another 16 by 3, and likewise at the top we would have a 16 by 3. So then we can find the area of all those 4 rectangles and add them together. So that's one option for that. Another option is that you could look at it as one entire rectangle. So one big rectangle, that's 22 by 16, and then take away the little rectangle in the center here. And that little rectangle in the center, we already figured out this length inside is 16. We would still need to figure out this length of that little inner rectangle there. And to get that, we have 16 all the way across here, and then we could take the 3 from this part away from the 16 and the 3 from this part away from the 16. So 16 take away 3, take away another 3 is going to give you 10. So that inner rectangle is a 10 by 16 rectangle. So I'm going to solve it that way just to show you how that works, but both ways are absolutely fine to use to find the area of this shaded part here. So the area of the outer rectangle is 22 by 16. So I'm going to multiply those two numbers together. And 22 multiplied by 16 gives me 352 centimeters squared. But I need to take away the inner rectangle. So let me put the area of the inner rectangle there, which is 16 by 10, which is 160 square centimeters. So then my shaded area would be the difference between those two things. So 352 take away 160, and that leaves me with 192 square centimeters. So again, you could have broken it into the rectangles that I talked about it at the beginning, which would have been 4 rectangles of 16 by 3, or 4 times 48 should also have given you 192 for that one. All right, looking at part B here, it's a little trickier in terms of breaking into shapes that are familiar. This one, I think you have to be able to look at it as a whole rectangle and then subtract the half circle that goes with this. So the area of my rectangle here is length times width, or 9.2 times the 13, length times width there, 9.2 times the 13, and when I put that into the calculator, I get 119.6 square meters. And then I want the area of the semicircle there. So the area of the semicircle that I'm going to take off of there. Now the area of an entire circle is pi times radius squared, but if I'm taking only half of that circle, I want to divide that by 2. So there's my little formula. Now the question is, what is the value of the radius for that circle? Remember, the radius goes from the center to the outside. It's that length right here. It would be half of the entire length across, which is the 9.2. So we're going to take 9.2 and cut it in half, or divide it by 2. And that would give me a 4.6. Okay, so that's the radius that I'm going to use in my formula for my circle. So we have our 4.6 to the exponent of 2, and then we're going to take that answer and divide by 2. So you can put that into your calculator all in one step. Remember, find where your pi button is. Use your pi times, and then 4.6 to the exponent of 2. Make sure you do that 4.6 to the exponent of 2. Don't times by pi first and get that answer, and then exponent of 2. The exponent of 2 is only being applied to the 4.6. When you do that and then divide by 2, I believe your answer is 33.2 approximately. All right, so then my shaded area is the difference between the entire rectangle and the semicircle. So the shaded area would equal the 119.6 minus the 33.2. And that, putting that in my calculator, I get 86.4. 86.4, and that's going to be meters squared. And I just realized I missed my meters squared there. All right, so a couple different ways to find area of composite figures.